Okay, so momentum, what is it? Some of you were approaching definitions of momentum. It is a vector. It's got a direction as well as a magnitude. And momentum is equal to mass and velocity. So those of you who said, it's something about mass and velocity, maybe that was how long it takes to stop. But anyway, they're related. It's the product of an object's mass and velocity. If I have a Honda Civic full of cotton balls going the same speed down a straightaway as a semi-truck trailer full of cement blocks, one of them has more momentum than the other. That would be the semi-trailer. If I take, it's the Olympic season. If I take let's put a couple people on luge sleds. So let's take an NFL linebacker on a luge sled and a jockey. One of them has got more momentum than the other. Yeah, the 350-pound guy has got a lot more momentum. Has anybody here ever... Okay, how many of you have ridden bicycles? Good. Okay, if not, you have homework. It's going to be tough this time of year, a little chilly. Years ago, I had a friend who had done some bike racing, and he was not the guy who you would look at and think was a traditional bike racer. He was a big guy, like 6'2", 300 pounds, big guy. And he said, man, I kill them on the downhills. They hate me on the downhills. I hate them on the uphills. So explain that. Okay. His mass did a great job of providing him with momentum on downhills. The little light guys who he was racing against had not nearly as much momentum on the downhills as he did. However, he had to get that mass moving up a hill. They had less mass to get moving up a hill. Okay? So, that's momentum. Now, we asked this question when we talked about kinetic energy. Ke equals 1/2 mv squared. Which was more critical for kinetic energy? It was velocity. Looking at the equation for momentum, which piece is more critical? P equals mv. How many of you would say mass? How many of you would say velocity? How many of you are chicken and you're abstaining?
No, I'm abstaining.
Ah, okay. How many of you would say this is a trick question? Good. Fantastic. And some of you are still chicken and abstaining. Okay. It is a trick question. They're equally important because it's just a product. Their influence is absolutely 100% equal. So and we can work out balancing out momentum for two objects. For that Honda Civic full of cotton balls versus that semi-trailer truck full of cement blocks, we can do the math to figure out at what velocities they will have equal momentum based on their different masses. Same thing for the linebacker and the jockey on luge sleds, which would be kind of entertaining, actually. Okay, we'll examine these briefly, but not right this instant. I think you can all handle P equals mv. Not too tough. Okay, now, if you're going to change momentum, this requires that a force acts on something. If you're changing your momentum, you are changing either your mass or your velocity. What do we know about changing velocity? What does it require? An unbalanced force. So, we've been doing that since chapter 4. Since the beginning of chapter 4. The force that is exerted to change momentum is equal to the change in momentum over the change in time. Now, okay, I want you all to imagine yourselves on a luge sled. Have any of you been watching the luge? Terrifying, insane. What kind of lunatic puts themselves on two little someone died in the last Olympics. Two little tiny metal runners and about half a square meter's worth of what looks like cardboard to me down a track where you're going to go 85 miles an hour and it's you and your helmet.
Is it like a straight down track?
Oh, no.
Is it like bobsledding then?
It's like bobsledding, but it's just you and you're basically, it's like a naked you with two runners under your butt.
That's
I mean,
awesome.
Okay, you can have it, buddy.
No rush. You know, you fly off the track and you
No.
die. How do you slow down?
No,
You just
you're just holding on.
How's an Olympic sport? It's pretty much just like you're going.
Yeah, we had this conversation at home the other night, but we'll talk. Apparently there is some athleticism and finesse involved in driving the luge
Like you
with
turn
subtle
yourself.
movements
It's like
of,
going
yeah,
on a hill Olympic
very
sport.
subtle movements of your body, but it's subtle. Anyway, so we're gonna put all of you on luge sleds.
Let's do it.
We'll put you on a little tiny baby hill. We'll put you on the bunny hill, okay?
The bunny hill for losing.
The bunny hill for luge sledding, yeah, it goes uphill. Okay, so if we are sending you all down the luge track, I want you to imagine yourselves rocketing down the luge bunny hill at a breakneck, I don't know, 1 mile an hour or something. Woo-hoo-hoo! Yeah. So you have some amount of momentum. Your mass, you're probably all between about 50 and 75 kilograms. Your mass times your velocity. We'll say we're going, that 1 mile an hour is what, a breakneck, like 9 meters per second, 5 meters per second, something like that. So your mass times some velocity. Now, you're on the bunny hill, remember? We're going to crash you into something. Oh no! A foot-on collision, because of course the luge sledders are going down pointy toes first. It's a foot-first collision here. You have options. Don't say I didn't give you options. Which would you rather crash into? The ice wall? Anybody want to pick the ice wall right off without hearing their other options?
The ice is right there.
The ice is right there. Or one of those big crash pads they use for the high jump and track.
I think the ice wall.
You taking the ice wall? You don't want the big squishy crash
It's
pad?
not really that. If you
No,
hit
it's
that
not.
fast.
It really is.
You're only going 5 meters a second.
That's true. Then just not take a
You take the crash pad? Okay. Okay. I would pick the crash pad.
It's not gonna hurt that bad. You're only going 1 mile an hour.
Well, you might have a little padding.
I'd take the padding. Okay, so intuitively, well now let me ask you this. Aside from what you would choose, which do you think is going to hurt more?
Probably the ice wall.
I think the ice wall is going to involve some pain.
How big is the ice? Like, if
It's
you're
like
gonna
a brick
just break
wall of
through it,
ice.
If you die, you
If
No.
you hit the
Have
wall
there
and it
ever
wasn't
been
a brick
soft
wall, it
ice?
would've been-
It's brittle, however. It is brittle.
How
Yeah.
big is
Okay.
How big is the ice wall?
I'm thinking